Welcome to Trainsignal. You're watching the role of DNS in Active Directory. In this lesson, I'm going to give you an overall introduction into DNS. We'll take a look at DNS domain namespaces, DNS queries, DNS forwarders, DNS zones, and DNS records. And that should give you kind of an overall understanding on exactly what DNS is and how it works. And then we'll wrap things up by seeing how DNS interacts with Active Directory. So to get things started, let's just look at a basic introduction into exactly what DNS is. Now, first of all, the letters themselves, DNS, stand for the Domain Name System. And what does this mean? Well, the Domain Name System, or DNS, is used to translate domain names into IP addresses. So for instance, when you go out and visit your favorite website, so we'll say www.trainsignal.com, well, that's a domain name, but the way your computer actually pulls up Trainsignal's web page, the way it communicates with the web server here at Trainsignal is via IP address. Now, why do we do this? Why do we want to translate a name into an IP address? Well, if we didn't, then we as humans would have to remember the IP address, these kind of random numbers that associate with the different domain name locations. So basically, DNS allows us to be stupid humans. We don't have to be as smart as the computers. We don't have to remember all those random numbers. We just have to remember simple names or common names, names that are easy to remember and usually will associate with what the resource is that we're looking for. Now, there are three main components to DNS. We have our DNS servers, the database, and clients. Now, I'm going to actually start in the middle with the DNS database. This is a database of domain names and their corresponding IP addresses. Now, the reason I started there is because the other two are real easy then. DNS servers are the computers that host the DNS database. They're the ones that store this database. And the clients, or the DNS clients, well, they're the ones that need to make a request of the servers to look up or resolve a name into an IP address. So basically, a client will say, I want to contact www.trainsignal.com, and it's going to go to a DNS server to make that request. The DNS server will look in its database, get the answer, and respond back to the client. Now, don't worry, I'm going to lay this out for you in a little more detail as we go through this lesson. So what is this domain namespace? A domain namespace is a hierarchical naming structure. Now, this is something that we actually saw in the last lesson when we were talking about Active Directory trees. As for instance, we talked about domains sharing contiguous namespace. And we learned that we had globalmantics.local, and then we had northamerica.globalmantics.local as being a child domain sharing contiguous namespace. Well, in reality, the overall domain namespace starts right up here at the top with a dot. Just a dot. That's the very top of this hierarchical namespace. This is what's known as the root domain. Now, below that, we move into our top level domains, which, as for instance, might be .net or .com or .org, things like that. Those are some of the common ones that I'm sure you're familiar with. And then from there, we move into our second level domain names, which is, in the case of the internet, it's most of our company names. So we have globalmantics.com as a for instance. That would be the external facing domain name for the Globalmantics Corporation. Or maybe we have Trainsignal.com. And from there, we can even go down into subdomains and end up with some fully qualified domain names. So here is, for instance, in Globalmantics, we have our headquarters subdomain, and then in headquarters, we have our sales domain. Okay, so we're just continuing down with multiple subdomains, and then an actual host, an actual computer whose name is server A. So the fully qualified domain name for server A is actually server A, right? That's just to begin with the actual host name, .sales, moving to the bottom level domain, .hq, okay, going up to the next level up in the hierarchy, .globalmantics.com. Again, just continuing up, .globalmantics.com. Now, technically, there should be a dot at the end of this fully qualified domain name. But again, as humans, we don't worry about that final dot, and all browsers, as for instance, automatically associate that dot without having to have it actually typed in or actually even printed on the screen. So what is a DNS query? Well, a query is a request for name resolution directed from a DNS client to a DNS server. Now, there are two different types of queries. One type is called iterative, or I've heard it called iterative. Doesn't really matter how you pronounce it, as long as you understand what it is. An iterative query is one where the DNS server is going to answer this query, this request, as best it knows how. Okay, so with an iterative query, I'll tell you what I know, but that's it. That's all I will tell you. Even if all I know is maybe you should go ask that DNS server over there. Okay, and we'll get to what that's called in just a moment. But an iterative query is I will look in my own personal database and I'll tell you what I know, even if that response refers you to another DNS server. Now, a recursive query is one where the DNS server will go ahead and research the answer for the client. So in this case, with a recursive query, the client will make a request to the DNS server. The DNS server will look not only in its own database, but it will then go out and research from other DNS servers that it knows about before giving a response to the client. Now, I have some illustrations to show you exactly how this works in just a moment. But first, let me explain that a DNS server can be known as what's authoritative or non-authoritative for a particular area of DNS namespace. An authoritative server, so a server that is authoritative over a certain DNS namespace, can either give the answer that is needed or an authoritative no. Now, the authoritative no, so that's the dad in me. I have 4 kids, so that's the dad in me coming out saying authoritatively, no, you cannot do that. In this case, the authoritative no is basically a DNS server saying, no, there is no host with the name you are looking for. A non-authoritative server will either use its cache. Now, cache is something we're not really going to get into. To simplify what the DNS cache is basically once a DNS server looks up a name, so it goes out, it's responding to a recursive query, and it's going out and it's researching what the name resolution is. Before sending it to the client, it'll put it in its own cache, which is an area of memory, so that if that request ever comes in again, it will know the answer without having to go out and research it. So a non-authoritative server will either look in its cache or it will use what's called a forwarder, which is, again, something we're going to get into here in just a moment, to go out and look up the answer from another DNS server. So let's take a look at exactly how these queries work. Here we have a client making a recursive query for the location of www.globalmantics.com. And it's making that query to its own local DNS server. In other words, in the client, when you set up its IP address and subnet mask and default gateway and things like that, well, you also set it up with the IP address of a DNS server, a server that is going to make these queries with. So it goes out to the local DNS server. The local DNS server, well, the first thing the local DNS server will do, and I don't have it illustrated here, is it would look in its own local cache and its own local database. Assuming that it doesn't have the answer. Okay, so this local DNS server says, I don't know who www.globalmantics.com is. Because it was a recursive query, it doesn't respond back, I don't know. What it does is it goes out and researches on the behalf of the client. So it does what's called an iterative query to the root DNS server saying, hey, I'm looking for www.globalmantics.com. Do you know who that is? Now again, the root DNS server, these are the servers out on the internet that represent dot. Okay, they represent the dot domain namespace. And when we get into the actual operating system, I will show you something called root hints, which is a list of the IP addresses of the root DNS servers out on the internet. And that's how the local DNS server knows where to go. But anyway, it goes to root and says, do you know who www.globalmantics.com is? Now, this is an iterative query, so the root DNS server is going to answer with whatever it knows. And it basically says, I don't know who www.globalmantics.com is, but I do have an entry here in my database for some other DNS servers, some child DNS servers called .com. So it responds back, why don't you ask .com? Okay, so when I say that an iterative query will always get a response, even if that response is go ask somebody else, well, that's what's happening here. The root DNS server is saying, go ask .com, see if that DNS server knows. And it will reply back, by the way, the IP address of a .com DNS server. From there, the local DNS server will go ahead and make another iterative query to the .com DNS server. Do you know who www.globalmantics.com is? And that .com DNS server say, no, I actually don't know who that is. But I do have an entry here for globalmantics.com. Now, real quick, before we finish out this illustration, if you've ever registered your own .com, so to speak, okay, if you have your own company name and you've registered it with a .com server or a .net server or something like that, you know what you're doing? You're putting an entry into the .com DNS servers so that when this process takes place, the .com DNS servers can then respond back with ask your company name.com. And what it's going to give is it's going to give the IP address of your company's DNS servers. So in this case, the .com DNS server gave a response with the IP addresses of the globalmantics.com DNS servers. So the local DNS server then goes and makes a third iterative query out to the globalmantics.com DNS server and says, hey, do you know who www.globalmantics.com is? And this particular server is authoritative for the globalmantics.com namespace and says, aha, I do have an entry here for www. So here is an authoritative response. Now that authoritative response could have been the IP address of the server that we were looking for, or we should really just say the host we're looking for. It may not be a server. Or that authoritative response could have been, no, that host doesn't exist. But in this case, the host does exist, so it responded back with an IP address, and the local DNS server then sends that IP address back to the client. Now, as far as the client was concerned, all it knows about is that it sent a request one way and got a response back the other way. That's all it knows. It doesn't need to know about the whole process that takes place in between. Now here's a name that I've already mentioned in this lesson, forwarder. So what is a DNS forwarder? A forwarder is a DNS server to which other DNS servers forward queries. Now there are two different types of forwarders. There's a standard forwarder, which is just where a DNS server has been configured to say if you don't know the answer to a particular query that has come your way, go ahead and check with this other DNS server. Or we have conditional forwarders, which is where it is conditional upon a specific DNS domain namespace. So a given DNS server may be set up to go check with certain other DNS servers for certain names. So it may be set up to go to a specific DNS server for globalmantics.com, and maybe set up for a different DNS server for Trainsignal.com, and maybe set up for a different DNS server with a standard forwarder for everybody else. So again, let's take a quick look at this here. How does forwarders work? Here we have a client making, once again, a recursive query to its local DNS server for www.globalmantics.com. Once again, assuming that the local DNS server does not know the answer to this question, because it was a recursive query, it's going to go out and look on the behalf of the client. So the local DNS server actually becomes a DNS client of its own and makes a recursive query to the forward DNS server. And this, again, would be another DNS server that the local DNS server has been programmed with to do these lookups. So the local DNS server now makes a recursive query for www.globalmantics.com, assuming that that forward DNS server also doesn't know. It's going to go out and do all those iterative queries to the root DNS server, and then down to the .com, and then down to globalmantics.com to get the authoritative response. Once it has that response, it sends it back to the local DNS server. And guess what happens next? You got it. The local DNS server sends the response back to the client. Now that's if we were using a standard forwarder. If we were using conditional forwarding, we might have a situation where a client will make a query for www.globalmantics.com, and the local DNS server has been configured specifically to go to this DNS server for any globalmantics.com requests. Any other requests, it goes out here to the root DNS server. Okay, this would be a situation where we're using a conditional forwarder for globalmantics.com. Maybe that's a company that we do lookups for all the time, and we know the IP address of their DNS server, so we program it in. But then we go to root hints for everybody else. Here's another example. If we were to do a query for server1.globalmantics.com, in this particular scenario, you'll notice that we are set up for a specific DNS server if it was asia.globalmantics.com, but that's not what we're asking for. We also are set up to do a specific DNS server for na.globalmantics.com, but once again, that's not what we're looking for. So what we're left with is, well, root hints, go out to the root DNS server, and then do all the iterative queries to get our answer for server1.globalmantics.com. But if we were to make a request for server1.na.globalmantics.com, then the request would go directly to the na.globalmantics.com DNS server. And again, this is because we've been specifically configured. Okay, this local DNS server would have to be specifically configured to do that. And then here, if we were to look for server1.asia.globalmantics.com, then the request is going to go straight to the asia.globalmantics.com DNS server. Now, if we were to look for www.trainsignal.com, where are we going to go? Yep, we're going to go, just like before, we're going to go to our root hints. Why? Because we don't have a conditional forwarder set up for the Trainsignal.com namespace. So that's how conditional forwarding works. So now let's talk a little bit about something called DNS zones. Now there's a number of things we need to look at when it comes to overall understanding of DNS zones. We need to first answer the question, well, what is a DNS zone? We need to look at the different zone types. We're going to talk about forward and reverse lookups and dynamic update. So what is a DNS zone? Well, a zone is an area of the DNS namespace to which a DNS server can be authoritative. Okay, so here you'll see that we have a whole hierarchy drawn out. And you'll notice I've switched now from globalmantics.com, which would be the external internet facing portion of the Globalmantics Corporation, to globalmantics.local, which is what we're going to use for our internal Active Directory namespace. So you're already starting to see the first signs here of how this associates with Active Directory. But here we have globalmantics.local, which could be broken down into subdomains of North America, headquarters, and Asia. And inside North America, we might even have a subdomain for support and training, and in Asia, one for sales. Now in this illustration, you'll notice I have this extra circle here around support and one around training, and that's just to illustrate that we might have a specific DNS server that is authoritative for those specific zones, meaning the server that is authoritative for the support zone is actually authoritative for support.na.globalmantics.local. Whereas the server that is authoritative for training is authoritative for the training.na.globalmantics.local namespace. That's its zone. But over here, you'll notice that I've got this big oval around Asia and sales. And the reason why is because that is to illustrate that we could have a DNS server that is authoritative over that entire area of namespace. It's authoritative for asia.globalmantics.local, and it's also authoritative for sales.asia.globalmantics.local. Okay, so just understand that a zone really is synonymous with namespace, other than the fact that we use the term zone to distinguish that a specific DNS server is authoritative for that area of namespace. Now let's take a look at the different zone types. First of all, we have primary. A primary zone, and I guess technically this should say standard primary. That's the official name. Standard primary is the master copy of the database. If as a DNS server, I'm hosting a primary zone, that means that I have the master read-write copy of the database for that area of namespace. Whereas a secondary or standard secondary, this is a DNS server that is hosting the database, but it has a read-only copy of the database. A stub zone is one that only contains information about other DNS servers, and we're going to look at this in just a moment as far as why we would use a stub zone. This has to do with dynamically allowing parent DNS servers to learn about child domain servers, or really DNS servers which become authoritative for child domains would be the right way to word that. We'll come back to that in just a moment. And then we have our Active Directory integrated zones. There's that name, Active Directory, right? Isn't that what this course is about? It's all about Active Directory, and that's the whole point behind this lesson, is that we're seeing how DNS relates with Active Directory. So again, here's kind of your first taste of it. Active Directory integrated zones are one where the DNS database is stored as an Active Directory object and is replicated within the Active Directory database. Again, we'll look at that in just a moment. First of all, let's talk about subzones. DNS allows for something called delegations. A delegation is where another DNS server has been delegated the authority over a subdomain. So I may be a DNS server which is authoritative for globalmantics.local. There is a domain that we create called na.globalmantics.local. So we may delegate another DNS server to be authoritative over na.globalmantics.local. Now, before we had stub zones, all of these delegations had to be managed manually. So if a second server, or a third, or fourth, or fifth, etc., were to come online and we wanted it to be authoritative over na.globalmantics.local, we would have to manually add it to the delegation on the DNS server, which was authoritative for globalmantics.local. A stub zone allows for the automatic propagation of delegations to the parent DNS servers. So let's go take a look at this. here we have the DNS servers that are authoritative for globalmantics.local. Right? You'll see here that we have New York DC1 and New York DC2. Okay, these guys are what's known as authoritative for globalmantics.local. Now, by the way, if you're thinking to yourself, wait a minute, I don't have these servers. What do you mean they're authoritative? We're going to get this all set up a little bit later. But for right now, I'm telling you, okay, I've got these two servers, and they are authoritative for globalmantics.local. Down here, we have one DNS server which is authoritative for na.globalmantics.local. And in the case of a stub zone, what we're going to do is we're going to manually create the zone telling the parent DNS servers about the one server that is authoritative for na.globalmantics.local. But by doing it in the form of a stub zone as opposed to an individual manual delegation, when we add a second DNS server, which is also authoritative for na.globalmantics.local, okay, so we've added this server in, the addition of this server will update what's called the NS records. Oh, there we go, jumping ahead. We haven't talked about records yet, but the NS or name server records for that particular zone, that will get replicated to Chicago DC1, which was the original DNS server authoritative for na.globalmantics.local. And then that server will automatically be able to update the parent DNS servers so that they can then know about the new child DNS server. Or really, again, it's not a child DNS server. It's another server that is authoritative for a child domain. So that's how stub zones work. I mean, to kind of simplify it, stub zones, dynamic delegations. That's kind of like the buzzword, remember, dynamic delegations. Now let's talk a little bit about Active Directory integrated zones. Now I already mentioned that with an Active Directory integrated zone, the database, the DNS database for that zone is stored as an Active Directory object. It's not a literal database on a local server. See, that's how it is with standard primary and secondary zones, is you have an actual database stored right there on the local hard drive of the DNS server. In this case, it's an Active Directory object. So what are some of the benefits? Well, first one would be multi-master replication. Okay, rather than having a single primary and then however many secondaries that you need, in other words, one master copy and then a bunch of read-only copies, now every DNS server has the master copy. And this is because Active Directory works in a multi-master environment where all domain controllers all have a read-write copy. Now again, don't completely freak out about this. Later on in the course, we're going to talk about Active Directory replication and how that all works. But right now, just understand that Active Directory does support what's called multi-master replication. That eliminates single point of failure. It also streamlines data replication. Why? Well, because instead of having this database sitting on a local hard drive that has to be replicated between the primary and the secondary DNS servers, it just replicates as part of Active Directory. And again, when we get into Active Directory replication, you'll see that it is a very efficient process, only updating changes and only updating in a fashion that is efficient and in some cases compressed to take advantage of the appropriate bandwidth. But again, I don't want to confuse you now with all kinds of replication stuff. Just want to give you a benefit here of an Active Directory integrated zone. It also supports something called secure dynamic updates. Now, we haven't talked about dynamic updating yet, but basically, dynamic updates is the concept of the DNS database being able to be updated by the clients as opposed to having an individual IT administrator having to go in and manually update the records. Well, Active Directory integrated zones helps to secure those dynamic updates by only allowing clients who are part of the Active Directory domain to be allowed to update the database. And the last benefit here is that Active Directory integrated zones are backward compatible to secondary zones. So if you have an old DNS server, whether it be an old Windows DNS server or maybe a Unix DNS server or some kind of DNS server that doesn't support Active Directory integration, that's okay. If you still want to use that DNS server, you just make it a secondary read-only DNS server pointing to the Active Directory integrated zone as its primary. So as you can see here, there are a lot of benefits to Active Directory integrated zones, and it is recommended that you use them anywhere possible. Now, as far as forward and reverse lookup, forward lookup means that we are resolving names to IP addresses, right? That's what we said DNS was used for, to take a name and turn it into an IP address. That way, we can remain stupid humans and just remember names, and DNS will turn them into IP addresses. This is widely used. A reverse lookup, well, it's kind of just what it sounds like. It's the reverse. A reverse lookup resolves an IP address to a name. Now, you might be thinking to yourself, wait a minute. Why in the world would I ever put in an IP address and then want DNS to tell me the name for that IP address? Well, there's not a lot of need, and that's why it's not always needed. It's usually used to meet the needs of a particular application. There are certain applications out there that have the need where it's not stupid humans anymore. Now it's a program, and that program knows the IP address, but now it needs to know the name, maybe to give back to the stupid human, right? In other words, maybe an application knows the IP address and it's doing something with that IP address, and then it wants to display the name of the computer that represents that IP address so that the human that's looking at this application will know what it's talking about, because they look at an IP address and go, I don't know what that is. I need to see the name. Which, by the way, I suppose I should mention here, because I've now said stupid human quite a few times. And I hope you're not taking offense to that, because it takes one to know one, right? And I too am a stupid human. So I'm saying that all in good fun. So hopefully no offense taken there, right? All right, so let's move along here. Dynamic updates. Well, I just told you a few minutes ago. Dynamic updates is where we have records being dynamically added or updated if there's a change made by the clients. Before we had dynamic updates, all DNS information was manually key punched in by an IT administrator. You'd literally sit at a DNS server and you would type in server A is IP address blah blah blah. Server B is IP address blah blah blah. Client 1 is IP address blah blah blah. Now, those computers will dynamically communicate with the DNS server and say, hi, I'm here, and this is my IP address. Now, dynamic updates, although it's quite handy and saves us a lot of time of having to manually update our databases, there can be security issues with dynamic updates, because if we're not using secure dynamic updates, anybody who has access to the DNS server, when I say access, I don't mean physical access, anybody who has the ability to communicate with DNS server has the ability to go ahead and send a dynamic update to the zone. So you could probably imagine how hackers, if they can get to your DNS server, can make modifications to your database. And I'll tell you what, you make a modification to a database, that can completely change where somebody goes when they think they're looking for a certain computer. Somebody's looking for server1.globalmantics.local, and they get the IP address of some other server that some hacker has put out there on the network. The client machine will think it's communicating with server 1, but it's actually communicating with another server. That can be dangerous. I've seen this with spyware that will update DNS zones. And to be more specific, they usually go into something called the host file, but that's a whole different lesson. We're not going to get into that. But basically, they update the database so that when you're looking for some common website, so we'll even say you're looking for Trainsignal.com. Well, if they've updated some kind of record on your DNS server so that it says, well, anybody who's looking for Trainsignal.com, here's the IP address. So that DNS server already has it, but that IP address points to an adult website, a pornographic website. That is something that spyware does very often. So if you've ever been in that situation where you've put in a legitimate name in your web browser and you ended up with a bunch of naked people on the screen, well, that's usually because spyware has found a way to update the DNS database either on your local machine via the cache or the host file or on the DNS server itself. So how do we get around all that? By securing the dynamic updates by using Active Directory integrated zones so that only clients that are known to the DNS server, and they are known to the DNS server via Active Directory, so clients that are part of the Active Directory domain, are allowed to make these updates. Now, one other quick little side note here is that dynamic updates can also be integrated with other networking services, for instance, DHCP. And what I mean by that is you might have a client, and I know we haven't gone into DHCP, but if you're familiar with it, you might have a client who says, hey, I need an IP address. A DHCP server says, here you go, here's your IP address. And then the DHCP server, on behalf of the client, can communicate with the DNS server and say, hey, I just gave out this IP address to this client. Why don't you go ahead and put it in your database? So there's quite a bit that can go on here with dynamic updates, but the idea is that the database gets updated automatically without anybody having to manually key punch it in. All right, now here's a term that I mentioned just a little while ago, records. So let's talk about the different types of DNS records. And there's a number of them that I have listed here, although I will tell you this is not all the different types of DNS records. These are just some of the more common types of records. You have your A record, or what's known as a host record, and this is your typical name lookup record. In other words, when you just want to look up the IP address of a computer based upon its name, you go to the A record. You have a PTR record, or a pointer record, and this is also what's sometimes known as a reverse lookup record, because this is the type of record where you would give the IP address and it would resolve back to the name. We have an SOA record, start of authority record, which has to do with delegations and what DNS servers are authoritative for what zones. We have SRV records, or service locator records, which have to do with pointing to what servers provide what services if you're looking for a certain service on your network. NS record, now there's the one I actually mentioned just a little while ago when we were talking about stub zones. Those are the name server records. Those represent the names of DNS servers that are authoritative for a zone. We have MX records, which are known as mail exchanger records, which have to do with, well, email. Okay, if you're looking for an email server for a certain name or area of namespace. And then we have the CNAME, which officially stands for canonical name. I've heard it referred to as common name or alias. And this is basically where, for instance, when you go to your favorite website and you put it, so let's say Google, and you put in www.google.com, do you think that Google has a server that's actually named www? And then you go to www.microsoft.com. Do you think that they also have a server named www? Or you go to www.trainsignal.com. Do you think we have an actual server named www? Well, I don't know. I can't speak for all the different companies, but I can tell you this. It's very common that the actual name of a web server that's hosting a website is not www. It might be like web server 1 or something like that. The CNAME is the alias. So there would be an entry for www, and that would be a CNAME record that tells the system, hey, anybody looking for www, actually, that's web server 1. Okay, so these are some of the different types of DNS records that are out there. And in just a moment here, I'm going to show you how some of these records work specifically with Active Directory. So let's get right into that. How does DNS interact with Active Directory? Well, we've pretty much, believe it or not, already answered this question. Okay, as I've been going through talking to you all about DNS, I've already shared with you how it interacts with Active Directory. Now, the first way it interacts with Active Directory is through the use of Active Directory integrated zones. As we saw, this provides multi-master replication, streamlined data replication, secure dynamic updates, and is also backward compatible to secondary zones. Okay, so that's one way that DNS associates, we'll say, or interacts with Active Directory. The other way, and this is an extremely important concept to understand. I really cannot emphasize this enough. Matter of fact, this is the whole reason that we are spending all this time in this entire lesson here talking. And that's because I need you, before going on to any other lessons in this course, to understand the importance of DNS in Active Directory. And it's right here. SRV resource records. These are the records in the DNS database which helps clients to locate servers with domain controller services. The idea here is basically when a client, when you sit down in a client and you press Control-Alt-Delete to log on, and then you enter your username and your password to log in to a domain, what your client computer does is it first goes to the DNS server and says, hey, I have a login request. I need to know where the heck I can find a domain controller. So first and foremost, we don't even know the names of our domain controllers. So we need to have these SRV resource records to find out the names of the domain controllers that we can log into for that domain. And to be more specific, and this is something way down the road in this course, is we will see how this can also help clients to locate domain controllers that are close to them, so that a user in New York doesn't try logging on to a domain controller in Chicago. This is an extremely important, matter of fact, I'm not even going to say important. It's a required component to make Active Directory function. If you don't have DNS appropriately set up to support Active Directory, Active Directory won't work. I've had a lot of emails and forum posts and all kinds of different things out there with questions from people saying, hey, you know what? I set everything up the way I think I'm supposed to set it up, and then I go and I have a client here and I want to join my Active Directory domain. And for whatever reason, even though I believe I have everything set up properly, I can't join the domain. My client keeps telling me, can't find a domain controller for that domain. And almost 100% of the time, I'll ask them, what DNS server does the domain controller point to? See, the domain controller, even though it's a server, it's also a DNS client because it needs to point to a DNS server to be able to update its records with that DNS server. So what DNS server does the domain controller point to? Okay, now what DNS server does the client point to? And like I said, almost 100% of the time, they won't be pointing to the same DNS server. So Active Directory might have set up properly because it is pointing to a DNS server that is set up to support Active Directory, but then the client's pointing to some other DNS server that doesn't have the SRV resource records to tell it where the domain controllers are. So this is vital. I mean, I'm sorry that I'm kind of beating a dead horse here, but this is vital to everything else. And as you are going along through the rest of this course, if you ever run into a problem, especially if it's a communication problem between clients and domain controllers, or domain controllers and other domain controllers, or anything that has to do with Active Directory, the first place I want you to look is DNS, because DNS is an absolute requirement to support Active Directory. Now, the other thing that I have listed here is I have A records listed, or host records listed. And the reason why is because the SRV resource records need to work in conjunction with the A records to truly service the client. Because the client goes to log in and it says, hey, DNS server, I need a domain controller. So the DNS server looks up into its database and says, okay, I have SRV resource records here that say that New York DC1 is a domain controller for globalmantics.local. Great. Now the client knows the name New York DC1. But guess what it has to do? That's right. It has to go back to the DNS server and say, all right, hey, DNS server, do you know the IP address so that I can communicate with New York DC1? And then there has to be an A record that resolves that name to the IP address. That is really how DNS interacts with Active Directory. And that takes us to the end of this lesson. So what did we cover? Well, we covered a lot of stuff about DNS. Gave you a basic introduction to what it is. We talked about domain namespaces, right, which is that hierarchical naming structure. We talked about all sorts of different DNS queries, iterative and recursive. And we saw how there's a process that we go through where a client will ask a local DNS server as a recursive query. And then because it's recursive, that DNS server will go out on behalf of the client and do a bunch of iterative queries to find that answer. We talked about DNS forwarding, which again is almost even a component of how DNS queries work, how that recursive querying works. But we also learned that there can be a standard forwarder, which one example of a standard forwarder is the use of root hints. And then we also have conditional forwarding, where we go to specific DNS servers for specific areas of namespace. Talked about DNS zones, which again, remember, a DNS zone is basically nothing more than a DNS domain namespace. It just represents that a server is authoritative over that namespace. Talked about the different types of DNS records, and to be specific, SRV resource records are the ones that allow DNS to interact with Active Directory, and really, I should say, allow Active Directory to function. And really, I should add to that, again, remember, not only do we have DNS supporting Active Directory through the use of SRV resource records and then the corresponding A records, but in general, we have A records so we can have name resolution throughout our Active Directory infrastructure. And then we also have Active Directory integrated zones, where Active Directory is actually now supporting DNS. So they really work together and support each other. All right, well, now that we have that out of the way, we can move on into the next lesson, where we're going to get right down and dirty and start touching things, touch the operating system, and get stuff installed and see how this stuff all works. And I look forward to seeing you in that next lesson.